I'm Dan Klein. I'm a senior here, and this is my departmental honors thesis. It's a program that, given a database full of plain text reviews for a product, can analyze the text and then suggest a user a rating based on what they've written in their review. Now, to achieve this end, I had to do this in two stages. One, to find a method of extracting features from a plain text review and then compiling it into data points, and then using these data points to predict or learn from past reviews what makes a 1-star review a 2-star, 3-star, 4-star, or 5-star review. Now, for our first point, the feature extraction, it helps to define what a feature actually is. And for the context of this thing, a feature is a pair of words consisting of a noun phrase and an adjective that describe an aspect of the product being reviewed. So for my test data, I used televisions. I just pulled a bunch of reviews off of Amazon, got all the text, got the scores in text files, and used that to send into a Java program. And some example features are like, if it had poor screen quality would be the noun phrase, poor would be the adjective, and you have excellent sound, polished exterior, things that describe aspects of a TV or things that people would look for when they're shopping for a new TV. And to do the extraction of these features, I used two different methods and compared them against each other for accuracy. The first one used this third-party program called WordNet, which is, as Professor Hodgson so adequately described, as a dictionary on steroids. It is a front-end thing that you can interface with in your Java program to connect to this database online to check to see if a word is a noun, an adjective, a verb, etc., etc. So what I would do is I would break each review down sentence by sentence and send each word to WordNet. I would check to see if it was a noun or an adjective. And depending if they are a noun or an adjective, it would then check to see if it was on this thing called a blacklist. Because what I found when I started comparing these words is that there are a whole bunch of words in the English language that are nouns or adjectives that I never expected to be nouns or adjectives, like be, be. I know it is a verb, but apparently it's a noun, and it messes with a whole bunch of my feature data. So I made this big list of stuff that I didn't want as nouns, so they wouldn't make their way into features, because a lot of stuff ended up being irrelevant. And then once it's done checking against WordNet and the blacklist, it returns here, and then features are then compiled from the nouns and adjectives. My second method was using this thing called the link parser. It's this program that I interface with my Java program that you feed the entire sentence into, and then it breaks it down grammatically. It makes a tree out of the grammar of the sentence, and then, thankfully, it does all the coupling for me into these noun phrases, prepositional phrases, etc. And all I have to do is just then extract the features from this parsed data, which is nicely labeled, and it's really nice, saves a lot of time. I don't have to write an algorithm for it. And the accuracy of each, I actually found that the WordNet blacklisting method was slightly more accurate than the link parser method. It matched a lot more of the human review that I checked it against. I had somebody go through all of the reviews to pick out the features individually, and then I checked the program output against it. And I found that WordNet got it missed less features than the link parser one, and generated more matches as well, and produced just about the same amount of false positive. That's things that the program would find that the human wouldn't. So then I've got all these features, and what do I do with them? I've got a whole bank. I think I ended up with like 100, 200, something like that. And I would use these to find out, based on the reviews that they appear in, if they were good features or informative features or features that you would like to have in a TV. Like, I doubt you would want awful screen quality or tinny sound in a TV that you would purchase. So what I would do is I would check to see the scores of the reviews which these features would appear in. And then the theory is that, good features appear in more good reviews and bad features appear in more bad reviews. So, judging upon what they appear in, it would give them a feature score, like a sort of average of, what sort of reviews they were appearing in. And then I would feed them into these artificial intelligence learning structures, and from there it would, given some data about the review predict or be told what sort of rating it has. And the first artificial intelligence structure I used was the decision tree, which is great for linearly separable data sets. That's things without overlap, or nice convex sets that you can separate using lines. And I use this program called Weka, which is developed by the University of Waikato, which I believe is in New Zealand. And it actually turned out quite well. It would take this input. You would basically get a bunch of input data points and a score label or an output point. And based on what you put in, it would form rules about what it learned. And then it would create this sort of flow chart for itself to sort of achieve the end. And this ended up being quite accurate, which surprised me because I didn't expect this to be linearly separable. And with my first test set of 51 reviews, using 19 of which to train the tree, I got 68% accuracy, which is pretty good. It hits more often than it misses. But with my second test set of 100 reviews, using 34, again, a third of the size to test it, I got 80% accuracy, which is actually quite well. 4 out of 5 reviews have correctly predicted the final score. And with this, the second artificial intelligence learning structure I used was a neural network, which basically functions like a decision tree, but it's a lot more complicated. It uses these activation weights and all of this stuff, and it's very black box. You don't really know what's going on behind the scenes. But it's modeled after the human brain, how it takes sensory input and generates some sort of output. And using that, it would feed these. It would take these 4 input data points, feed them to this hidden layer of these things called neurons, which make decisions based on the input given to them, and they all feed into this one big output neuron. And this output neuron is supposed to match up with the expected bit of data, in this case the score of the review. And the output for that didn't quite go as well. I couldn't get the error percentage to a reasonable level for consideration. Ended up being like over 100% error, which is probably something I did wrong. Not fault of the neural network, because I expected that to work a lot better than the decision tree, because I expected the data to be non-linearly separable, and neural network is supposed to be better at that. But I still need to work out a few kinks before it meets its final version. But that's just about it. Largely, I learned that. This is a completely viable way, at least using decision trees, to sort of predict scores based on the text of a review.